A camera star.
A camera
Earth Science Time camera stars. That's how Earth Science Time Zoe 101 fans. Okay, you guys remember Zoe 101 from the Disney Channel?
Yeah.
Do you?
Wasn't it Nick?
Yeah.
What am I thinking of? Is that even a real
Zoe
show?
101 was on Nick.
Oh. Okay. Other TV channels are available. Okay, we're talking about the rock cycle. And then we will talk about the specific specific types of rocks. What are we going to do first? Zoe 101 fans. Is that even a show?
Yes, it is a show.
Zoe.
What am I thinking of? Zach and Cody. Sweet Life of Zach and Cody.
Oh, I love that show.
Is that a real show, Camden?
Yes.
Yes, Zoe 101 is a real show. It was on
It
Nick.
was on Nick and it came out the year I was born.
Yeah, I remember it. I didn't remember. How did I even think of that? What is going on with my brain?
That was so great.
I am sick. Okay, I have an illness. Let's talk about, what am I going to talk about first here, Kyle? Kyle already knows how it is.
The rock cycle.
Yeah, well, yes, but I'm going to talk about the breaking of the through. What do we mean by cycle? What are some examples of cycle? Or what are some other ways we use cycle? What's a really common way we use cycle in our daily life, a lot of us? Bicycle, a bicycle,
No.
is two whats?
Two wheels together.
Yeah, and so that gives us a little hint. We should probably start this over. That gives us a little hint about what a cycle is. It's like a wheel. It's like a round. Round. I put. That's funny. I don't care who you are. That's a hilarious way to write round and round.
Yeah.
Let's take a little detour immediately after talking about what cycle means. And let's just list the types of rocks so we have something to fill in with our rock cycle.
We call it the sedimentary.
Yes, sedimentary. Sedimentary. Or sedimentary. Either is fine.
Igneous.
Igneous. Let's have one of our other homies do another one instead of just Kyla doing all of it.
Metamorphic.
That one was kind of...
Good job, brother, homie.
Good job, homie. I kind of tracked you on that one because you only had one left. You had to get it right. Which one of these would you like to start out with?
Let's talk about our boy Igneous.
Let's talk about our boy Igneous first. Let's put him down here. What are the arrows leading to our igneous rock? I tried to make this look like an igneous rock. Rocks can be any shape. Any rock can be any shape. Some of them, like we were just talking about obsidian, tend to have different shape. Like obsidian, because of the way it is, tend to have conchoidal fracture, and so they look kind of like anti-circular, like the edge. Instead of being a circle, they're like the edges are cutouts of a circle. So obsidian might kind of look like that. Anyway, what are all the arrows leading to igneous going to say?
It's
Like,
going to say,
how does igneous form?
it's going to say magma.
Magma. What process is leading to magma?
Volcano eruption.
Let's do what processes in purple. So objects are going to be in brown on my chart. You don't have to use multiple colors. Maybe you can use a different font, or you can underline them or circle them or whatever. But on mine, they're going to be different colors. What process leads to magma?
Volcano erupt.
What general physical process leads to magma? What must rock do to become magma? Specifically, not just heat, but melting. And then what specific process happens to magma to become an igneous rock?
Cooling.
Cooling. Specifically, freezing. That makes it sound kind of funny, because we think of, if I was to say I'm freezing, I wouldn't mean the temperature at which igneous rock cools from magma, which is 1100 degrees Celsius sometimes. I would mean I'm cold, but that's what it is. Anytime a liquid is becoming a solid, that's called freezing. We're going to have more than one of these, and one thing that we're going to talk about kind of a little bit later on too is that this igneous rock, what happens if the igneous rock, obsidian or whatever, melts and then cools again? What does it become?
An igneous rock.
Still an igneous rock. It might be a different igneous rock, but it's still an igneous rock. So this kind of rock, igneous rock, can melt and then cool again to become another igneous rock. So melting, cooling. Oops, sorry. I said cooling too. We can call it cooling. People call it cooling. In fact, cooling is probably a more frequent thing to call it than freezing. Both are right. Why is he drawing these same things over and over again?
Because it's a cycle. It
Because it's a
happens
cycle.
over and over and over
It
again.
happens over and over and over again. What are these other two little arms of the cycle that could become an igneous rock? I'm going to do them in a different color. Still be brown, but just a different kind of brown. Well, what could be over here that could become an igneous rock? Or that could become magma by melting, and then that could freeze to become an igneous rock.
It could become it could be sedimentary rock.
Now let's have sedimentary rock. Right there. How might igneous rock become sedimentary rock?
It breaks up into little pieces. And
Okay, and we call the breaking up in little pieces
Call it
what?
erosion.
No, that's...
Well, the pieces are sediment.
The pieces are sediment, so let's put that in our little bubble. I don't know why I said it like that. Sediments. So what happens to the igneous rock? You said it. You said what did you say? Because I can't remember.
Erosion.
Yes, that's one of the things that happens. So erosion, and we'll talk about this more in the future, but erosion is specifically what we call when it's moved. People use that to mean, like if I were to say, Camden, that my confidence in you has eroded, you would take that to mean that it had lessened, it had degraded, right? People use that word to mean broken down a lot, but really, specifically in geomorphology, in geology, we use erosion to mean the movement of sediment. So let's write that down actually over here. Erosion is the movement of sediment. There's another word for the breaking down of something to become sediment. What might that be? What goes along with erosion a lot of times? That means your book had it.
Weathering?
Yeah, weathering. Weathering. So weathering is the breakdown of rock to become sediment. And then erosion is the movement of sediment. And then after it is sediment, it's just loafing here as sediment. What happens to it that can cause it to become a sedimentary rock?
The sediments like go together.
Yeah, they get what we call lithified. They become rock. Lithified. Lithification. Which can involve compaction, can involve cementation where they're cemented together. It can involve interlocking, but all the other we call those processes lithification. And that comes from the Greek word lithos, which means rock. It means to be made rock. Can only igneous rocks undergo these processes to become sedimentary rock? No, just like an igneous rock, the sedimentary rock itself can undergo it. In fact, I would say probably if we tallied everything up, the most common type of rock to become sedimentary rock is other sedimentary rock. What else can become sedimentary rock besides igneous and sedimentary rock? Metamorphic. Weathering and erosion, I just abbreviated sediment lithification. I hope my abbreviations make sense for that. So now we know sedimentary rock can become igneous rock. What must happen for sedimentary rock to become igneous rock? Oh, my processes were supposed to be purple. I'm sorry. You don't have to change yours, obviously, but just because I told the wonderful people of YouTube that I need to now, and my 8 viewers are going to be so disappointed. I need to make these all purple, so we'll give me a minute. But meanwhile, answer my question. The question was, what must happen for a sedimentary rock to become an igneous rock?
It has to.
You had the end part, right? It must cool, but what must it
But
do
it has
first?
to heat and then.
Yeah, it has to melt and then cool to become an igneous rock. what's the one missing? What haven't we done yet?
We haven't done sedimentary rock.
Yeah, we actually have.
Igneous rock.
Actually, we've done both of those.
Metamorphic rock.
Metamorphic. Metamorphic. Could an igneous rock become a metamorphic rock?
Yeah.
Heck yeah, it can. What must happen to it to become a metamorphic rock? Extreme! What? Extreme what?
Pressure.
Yeah, both of those are right. Heat and pressure. Extreme heat and pressure. Could a sedimentary rock become metamorphic rock?
Yes.
Yeah. How? How? Let the record show that they're
Extreme
not
pressure.
ignoring, they're just writing. Yeah, extreme heat and pressure. And then metamorphic rock can also become another kind of metamorphic rock through extreme heat and pressure. Any bit of this, even like sediments, if sediments, I'm pointing at it, if sediments melted and cooled, even if we wouldn't usually specifically call them rock, I just got it, like, you know, the track, you see the track out there? That's sediments. If we had a handful of those and we melted them and cooled them into another rock, that would count as an igneous rock, even though we didn't start out as a sedimentary rock. Any of this can become any other part. It's not exactly like the water cycle. We talk about cycles in a lot of ways in science. It's not exactly like the water cycle where every step leads to another step. Like if the water vapor is already a gas, it can't evaporate and become a gas. It could condense and then re-evaporate. But at any point of this can become another point. It's less like a woo cycle and more like a all over the place cycle. So let's talk about now some specific kinds of these things. Are you ready? Are you done with this?
Yeah. Are you kidding?
I'll look back on the video.
Well, you have questions about it, or
No, I'm okay.
okay? Which specific type do you want to talk about first?
Let's go backwards. Let's do...
Metamorphic first.
Yes.
All right, let's do metamorphic first. I was going to give you not an excuse. I was going to tell you a reason why that's not the best idea, but I gave you the option, and you chose
Okay, now
metamorphic.
then
So
you correct me. Which way
no,
should
let's do metamorphic first.
Should we do sedimentary first?
We could do any of them first, including metamorphic. We usually classically break up metamorphic rocks into two categories. They are what we call foliated and non-foliated. Have you any idea what foliated might mean? Having to
Oh
do
no,
with-
like exfoliate.
Okay, and what does exfoliate mean, girl?
To like, I don't know. It's like,
It's more than just cleaning. What's the prefix X mean? If I was going to exterminate a wasp on my wheel, what would I be doing to it?
kill it.
Yeah, I would be ending it. I would be causing an end to it. So exfoliate causes a removal of,
Something.
yeah, folia,
Yeah.
which is the same root word as this. Where else do we see the root folia? There's beautiful foliage outside. What does that mean? The whats are beautiful.
The trees.
Yeah, specifically what part of the trees?
Leaves.
The leaves, yeah. When we talk about the beautiful foliage, we're not talking about the trunks of the trees. So this the root of this is just leaves. And the reason we talk about it with this is that they're not obviously they're not made of leaves. They're not made of leaves, but they are like little piles of leaves, and that's why we call them foliated if they are like little piles of leaves, or non-foliated if they're not. So the foliated metamorphic rocks will have layers or bands. And that's because as the heat and pressure is put on certain minerals, basically you can kind of think of it like this. If the minerals are, we remember about minerals, if they're roughly flat, even if they're not perfectly flat, but if they're roughly flat and enough heat and pressure is put on them, they will all line up perpendicular to the axis of the heat pressure. So if we put pressure on them this way, they're all going to line up this way, perpendicular to the axis of the pressure. So the pressure's down, and so they line up perpendicular to that. If they're not already flat, if the minerals are more, not necessarily circular, but not flat, no matter which way the pressure's coming from, they all just kind of get smaller into a little tiny box. This one should probably be smaller too. That's the thing about metamorphic rocks, is they do take up less room for their mass than other types of rocks. So what does that mean? They have a higher what usually? Yeah, higher density, because they have a greater mass in a similar volume. So foliated rocks or foliated metamorphic rocks have layers or bands, whereas non-foliated do not. The main, let's talk about non-foliated first, because there's two main examples. There are, listen, son, there are hundreds of different kinds of rocks. But the two main ones that we talk about in non-foliated, or at least the two most common that we talk about in non-foliated, are marble, which is metamorphosed. Verb metamorphose, what does that probably mean, just in context here?
Metamorphic. Like,
Yeah, it means to make it into metamorphic. So marble is metamorphosed limestone, which we would know about if we had talked about sedimentary rocks first, but that's okay. And I'm trying to figure out where to write this, but I'll do it over here. Quartzite is metamorphosed sandstone. What mineral is limestone made out of? Do you remember we talked about when we talked about minerals? I'll give you a hint. If we put some vinegar on, or some hydrochloric acid on limestone, it would bubble. What mineral is it probably made out of? It's calcite.
Yeah.
Calcium carbonate. Cocar. And quartzite is the silicate mineral quartz. I spelled it like an idiot. Hey, watch your profanity. Quartz. Which has the formula SiO2. So the foliated rocks, though, those are the non-foliated ones. Those are the ones where the quartz and limestone have a geometrically non-flat structure, and so when the heat and pressure are applied to them, they become these rocks, which are denser than sandstone or limestone, but otherwise fairly similar properties. They are less reactive, or at least the limestone is less reactive. Sorry, the marble is less reactive than limestone. And they're more useful probably for building materials because they're denser. They can withstand a larger amount of force without crumbling. Let's go back and talk about the foliated metamorphic rocks. We usually grade these in order, well, we even call them grades of metamorphism. Metamorphism. Grades of metamorphism. So from low-grade metamorphism, which would, there's kind of a gray area between lithification, where sediment becomes sedimentary rock, and metamorphism, where there's extra heat and pressure. But we start out with some kind of sedimentary or igneous rock. I suppose it could be metamorphic rock too, but we usually talk about it with these two to start with, sedimentary or igneous rock with platy minerals, and the platy there just means flat. So whether it's a sedimentary rock or an igneous rock doesn't really matter, but the mineral makeup it has have to have at least some flat minerals, such as mica would be a platy mineral. Any kind of mineral that forms clays would be platy. A lot of the silicate minerals can be platy. Mica is an example of that. Feldspar would be platy. They just form flat minerals, and so then as the pressure is applied to them, they all line up And depending on how well lined up they are and how tightly packed they are, they first become, so these are not, this is not metamorphism. These ones are metamorphic, these ones are not. So they first become slate. A lot of times the example we use for the beginning of this was shale. We'll say that they were shale to begin with. And then as they're metamorphosed, they become slate, and then they become phyllite, and then they become schist, and then they become gneiss. Make sure you spell those last two correctly. It's almost impossible to see what I'm writing on the board on the video, I guess, but
Is it SCHIST?
SCHIST is schist, and GNEISS is gneiss. Those are both German names. Usually I have examples of these minerals, or these rocks. If I had been thinking about it, I would have brought in some. But one thing that's kind of cool is that if we start with, sometimes it can be kind of hard for people to tell the difference between the sedimentary rock shale, which is made of clay minerals that are lithified, and slate, which are made of clay minerals that are metamorphosed. But one thing you can do is you can drop both, and the shale will sound like clunk, and the slate will sound like clink because it's higher. It has a higher density. Another thing you do is get them both wet, and you can smell, the shale will smell dirty because the minerals are loose, and when they're wet you can smell them, and the slate will not. And then obviously phyllite, schist, and gneiss are more metamorphosed, and so they would be denser and denser and denser. We are going to talk about igneous and sedimentary rocks, and I didn't realize that I love talking about rocks, and so this is, it takes a little bit of time for me to talk about the rocks the way I want to do it, so we'll probably, today we did the rock cycle and metamorphic rocks, and then tomorrow I think we'll probably talk about sedimentary and igneous rocks. And I'll bring examples of all three types so that we can talk about them better. Do you have questions about the two different broad categories of metamorphic rocks? And then I think it would be satisfactory to me if these are the 6 kinds of specific metamorphic rocks you know. If you know about quartzite, marble, which are non-foliated, and then slate, phyllite, schist, and gneiss, which are foliated, that would be satisfactory for me. There are other kinds of metamorphic rock, but those are, in fact, those are the ones your book lists too. Questions about any of this? Oh, one last thing before we go. What are some things that can probably cause metamorphism, causes of metamorphism? What do you think is the primary driving force on planet Earth that causes metamorphism?
Pressure?
Yeah, heat and pressure. But what force causes that? Yes, gravity. What do we call the system of gravitational interactions between different parts of the ground on planet Earth? We're going to call them, so the causes of metamorphism are regional, which is caused by plate tectonics. That's what I was trying to get you to tell me. You remember talking about plate tectonics in 8th grade science. We did it with the yogurt and the frosting and the green crackers. Plate tectonics, which is regional metamorphism. So the whole area of rock will get subducted and not melted, but exposed to high heat and pressure, which causes the whole area of rock to become metamorphic rock. There's also contact, which is due to contact with lava, touching magma. So the rock that touches the magma, but itself is not melted. That's what's really key about metamorphic rocks. Not melted. They are heated and pressurized, but not melted. If they melt and then cool, they become igneous rocks. And there's also hydrothermal, which is where they're touching hot water. And obviously the water would have to be hotter than we could ever have on the surface. Because can we have liquid water that is 500 degrees Fahrenheit on the surface of planet Earth? No, because it'll boil. But at the extreme pressures underground, water can be thousands of degrees Fahrenheit or degrees Celsius, and any rock touching that will be metamorphosed. And the last one, which I think is the coolest, is called impact, which is where a meteor strike will cause metamorphism in an area where the meteor hits. This one's very rare. In fact, I don't know if your book talks about it at all. The old book that I used to use didn't talk about it at all because we rarely come across it. It's interesting because people do study impact craters a lot. And since we can still see an impact crater hundreds of thousands or millions or tens of millions of years after it happened, it's still cool, and we still do talk about it. But so you should be aware of it. But these are the four main, or really three main and one cool, awesome causes of metamorphism. The other three are a lot more common, but the impact one's the coolest. Now you have a whole new thing. Do you have questions now?
What was the third one?
Hydrothermal. Hydrothermal. Hydro meaning water, thermal meaning heat. I'll have to adjust that camera.